For today, we are going to start a new chapter, which is chapter 24, which talks about Gauss's law. What is Gauss's law? It is a new method for calculating the electric field. We have already studied a method. This method came from Coulomb's law. We did an integration for integral k dq over r square in order to calculate the electric field generated by a distribution of charge, and we have also learned how to calculate the electric field created by individual charges or by discrete charges. So before going to chapter 24, today I'm going to just allow you to see some examples from exam.
عندكم صوت؟
ايه
بس سؤال، شو هو اللي كانت فاتحة عليهم الدكتورة؟
بدها تفرجينا examples من دورات.
الشابتر القديم يعني؟
ايه صح.
دكتور عم تحكي شيء؟
لا الدكتورة مش عم تحكي، بس شوية وقت راح الإنترنت عندها بكون.
اوكي.
I'm back. Sorry for the loss of connection. So I will reshare my screen. So quickly, they won't take time. I will pass over a question from first session of exam of 2020-2021. Okay, so this is the first problem. It talks about finding the electric field for sure of we have a bent wire, as you can see, and another part too, which requires to find the total electric field at O. So let's start with the first part. So everything is clear. I won't read all the given, but I want just to show you how exams or how questions in the exams appear and how to solve them. So let's start first with this part, which is part 1, when the radius r equals radical 3, so he's giving me the radius, the electric field EW, so W is the wire band, as you can see, it's marked in solid black, okay, created by the charge wire at its center O is, so we have to find the electric field here due to this arc that you are seeing, or due to this wire. This wire carries a linear charge density lambda equals 20 microcoulomb per meter. So he's giving me a positive linear charge density. So I have to take this into account when I solve and I find E. So how to find E? We have to apply the method that we have studied. We have to integrate. How to integrate? First, we choose a small portion of the wire, as I have did here. So I took a small portion of the wire and I have defined theta to be the angle with x-axis. Why did I say that? Because I felt it is easier. I can take the angle with y-axis, but it will be harder. So I have to say it will vary from -30 if I'm talking about y-axis till 180 plus 30. It will give me 210. So boundaries will differ, but at the end you will get the same answer. So always the geometry of the exercise will help you choose which angle, which one is more obvious and which one is easier. So أنا اخترت الانجل هي مثل ما انتم شايفين, it is the angle with x-axis. So I can see that the beginning of the wire starts making an angle theta equals 60 degrees because he gave me, let me just erase this part here. So because he gave me that the angle with y-axis is 30 degrees, so at the beginning here we have an angle of 60 degrees, and the end part of the wire, so the end part is making an angle of, for sure, we have 60 plus, this is 90 plus 180 plus 30, you will get, add all of them, you will get 300, or you can say 360 minus 60, it is the 300. So this is the initial angle and the final angle. Why do search for them? Because these are the limits of, or the boundaries of our integral. لما انا اعمل انتجرال على الثيتا تاعيتي, I've told you لما يكون شكل الواير circular, الفاريبل عندي is theta. I can choose theta either with x or with y, but I have to choose the boundaries correctly. Okay, so here the geometry of the figure يعني بيساعدني انه انا choose theta with x axis. I feel it's easier. Okay, so the beginning is making an angle of 60, the end is making an angle of 300. So let's go back. I will erase. I've explained this. Let's erase this. We take a small portion, as we have already done before, and we draw DE. So what is DE? DE is the element of electric field created by DQ at point O. Okay, how to draw DE away from DQ because lambda is positive. برسم DE. So after drawing DE, now I have to project along X and along Y. I have already defined theta, so أنا عرفت هيدي theta. So now I can project based on my theta. Okay, now before solving all of you should know, before solving this problem, that because the shape is symmetrical like this, symmetrical with respect, let's say symmetrical with respect to y-axis, so the electric field at the end will be like this. It is along the axis of symmetry, so it's symmetrical along x-axis, so the electric field is along the axis of symmetry of this bent wire, of this circular wire. هلا ليش away? Because my wire is positively charged. So it must be drawn, sorry, on O. So like this, it must be drawn on O. So my wire is positively charged, so the electric field at O must be drawn like this, away from the positive charge. It has no y component, it only has an x component. مثل ما أنا علمتكم, so it is always along the axis of symmetry of the wire, yeah towards the wire, yeah away from the wire. If it's positive, it's away from the wire. If it's negative, it is towards the wire. So if I look at my answers, or at my possible answers here, so you can see that all of them are along I direction. While all of them are along I direction, because we have no y component, we have only an x component. كمان we have other indications. We have 3 pluses and we have 1 minus option. We have never to choose the minus option. This is, if I'm talking, let's remember the physical explanation of the electric field. Because my charge is positive, so the electric field generated at O due to this wire must never be point towards the wire. It must always point away from the wire. So it's pointing away from the wire. That means it's pointing to the right. That means it must be plus I. Okay, so this is a general discussion. Now let's go through finding the answer. How to find the answer? Similar way as we have already done. We are searching for only dx, no need to search for ey. So integral dx, we substitute. Don't forget sine, magnitude, projection, sine or cosine. So we need to project here. So I've included a minus sign, then the magnitude. Okay, so because it's positive, no need for the absolute value, and cosine theta because I'm projecting along x-axis. As you can see, this is my dE and this is my theta, so this is dEx, which is the portion of dE along x-axis. Everything is okay. We replace dq by lambda dl. dl it's r d theta, the same way we solved in the exercises. We place our boundaries from 60 to 300. We get our answer. When we finish, we check our answer. Our answer must be positive. Why? Because we know that the electric field must be to the right. Otherwise, you have done something wrong with your boundaries. Just correct the sign. Okay, so just recheck your boundaries. If you have a mistake in the sign when you have finished calculating, so if you have a mistake in the sign, it means that you have a mistake in the boundaries. Okay, so what?
دكتور
What?
ليه أخذنا الباوندريز from 60 to 300؟
نحن because I have chosen to take theta, the angle being with x-axis. So because theta is the angle being with x-axis, as you can see, the start or the start of the wire begins at 30 and the end begins at 300. If you say, for example, from minus 30, from minus 60 to 60, then you mean this portion of the wire. Okay?
Okay.
Okay. As much as you solve, you will become better. Okay? هن أصلاً الشيبس are limited. يعني يا بده يكون شقفة من arc يا بده يكون نص arc يا ربع arc. ما في غير هيك. Okay, so as much as we become better. So is it clear here?
دكتور بس قصدي هي مش بتخلص عند ال 30 اللي من تحت.
هي شو؟
مش بتخلص من عند ال 30 اللي من تحت.
تخلص لحدهم. يعني هو هيدي الارك اللي انا راح لونه بالازرق. this one هيدا هو الارك تاعولي.
هذا بيطلع 300.
ايه على البدايه، ما انا وصلت على البدايه من هون لهون عندي 60 وانا عم باخذ الانجل من الاكس اكسس. يعني الاكس اكسس لعند النهايه هون 300. اجمعهم انت بيطلعوا معك 300.
بس ليش اخذناها من عند الاكس اكسس البدايه؟
لانه انا عرفتها الانجل من عند الاكس اكسس، وانا بعرف انجل. I usually define an angle and move on. I can't change the definition of the angle. انا بعرف من هيدا الخط الانجل تاعتي.
اوكي.
Okay, so please, if you have questions, leave them till the end because I have to explain a new lesson and I'll just pass over these problems rapidly. I won't take too much time because I have to finish the next chapter, which is explaining the next chapter. So here in part two, what is he saying? He wants me to find the charge that must be placed here. So I will just erase here. So he wants me to find the electric charge Q, big Q, that must be placed here, okay, at a distance r from O along x-axis, such that the total electric field at O is 0. So we have proved that there's an electric field at O, and this field it is directed to the right. So I will draw E. This is EW. E due to the wire. Anyway, if someone did not know how to find it, it's re-given down, but with a different value, because we can give you the same value up, so you will just find the answer. So we gave you a new value for EW. Assume they have changed R. So when R is changed, so for sure the electric field created by W will change. So he gave me EW, and he told me what must we place at Q, what charge must be placed at Q so that the total electric field is zero at all. So قبل ما أنا أشتغل لازم for sure to get a zero electric field at all, we have two sources of electric field. عندي the electric field created by the wire and the electric field created by Q. To get a zero electric field, the electric field created by Q must be directed to the left, like this. So this is EQ. It must be to the left. So to get EQ, it must be to the left. Okay, I'm talking about point O. I'm finding the electric field at point O. Q must be positive. Q must be positive. Why? Because EQ, which is the electric field generated by Q, is directed away from Q. Away from Q, it means Q is positive. So as you can see, all the options here, they are positive. This is the first indication. Now, if I need them to be zero as vectors, the sum of them is zero as vectors, so they must be equal in magnitude, opposite in directions. So I can say EQ vector plus EW vector is equal to 0, EQ vector equals minus EW vector, or as magnitudes, EW equals EQ. So because they are equal in magnitude, just substitute and find Q. هلا EW is the electric field generated by the portion of a wire, already given, no need to calculate it. EQ is the electric field generated by a point. By a point, it's an easy formula, no need to integrate. It's KQ over distance squared. What's the distance? It is big R, which is the radius. So we have everything. We have K, we have Q, we have EW. Just substitute and find big Q. And you have your answer. Okay, so similarly, I will just pass over another problem from, this is from first session. This is also from, I will close this one. This is, leave. Okay, from first session, 2019-2020. Okay, so as you can see here, this is the first problem. Also, it talks about the electric field. He asks me to find the electric field due to this distribution. First, he wants me to start with electric field E1 created by only part 1. So by this part, which is the arc. We have solved something very, very, very similar. We solved the same problem in exercises. Okay, I shall open it. Just give me 1 second. I will allow you to see it. So it was in chapter 23. Okay, so here it is. It must be here somewhere. It's down. So here it is. This is the same problem. This is the portion, same portion. So I've done my calculations using the same method. I've chose to define theta with y-axis. So this is theta, and my theta varies from 0 to pi. فيكم تاخدوها مع x axis, and it varies from minus pi over 2 to pi over 2. كمان you can do that, but the projection will change, as I have explained, and at the end you will get the same answer. So if you study well, you can solve. We have got the same answer. So 2k lambda over r. Let's check our solution when we solved. So it was the same. It was minus 2 absolute k over r, but it has the same form. The minus sign due because our wire was negatively charged, so there appeared a minus sign. It was opposite to x-axis. Here our wire is positively charged, so when I project, no need to insert a minus sign, and the result appears to be positive. Okay, so this is the only difference. مثل ما شايفين أنا عندي symmetry along x-axis, so there's no y component, there's only an x component. Electric field رح يجي على x-axis. Because my lambda 1 is positive, and he told me that, sorry, this is positive, and he told me that up, he said lambda 1 equals plus lambda. He means it is a positively charged density. So the electric field created at O, it is away along the axis of symmetry of this arc. So this is E1. This is E1. So before solving, you can see that the negative options, they are rejected. I have only two positive options. I've ended up with 2k lambda over r. You all know how to solve this. No one doesn't know because we have solved similar things. So we just substitute k by 1 over 4 pi epsilon 0, and you'll get the form that he gave us in part or in option D. Okay, so this is something you all know. What concerns the second part 2, بالنسبة للpart 2, okay, he can ask me to find the electric field of part 2. He assumes that part 2, okay, this is a finite straight vertical part, so it's a semi-infinite wire. It starts at R and it ends at infinity, so it's a semi-infinite wire. He may ask me to find the electric field there, and the electric field due to a semi-infinite wire, it is, as you remember, k lambda over distance over n whole over r, k lambda over r, and I have just to insert the sign. So كمان we have solved something similar when we deal with a semi-infinite wire or a segment where the point is along the same line joining, يعني نفس الخط طول الواير. لما تكون النقطة على نفس الخط طول الواير. Where is it? It is up. It must be here. Okay, here it is. Here it is. This is a semi-infinite wire. Okay, so you can see that our answer had a magnitude of k lambda over x0, where x0 is the distance between the point and the start of the wire. So لازم نحن كمان إذا نحن بنعمل هون same solution، بس بدل ما أحط دي x بحط دي y. نفس الانتجرال from r to infinity. Why from r? Because the position of the beginning of my wire starts at r. But he did not ask me to find the electric field here. It was much easier. So he just told me, guess which one is the true one. So you must guess one. What is the charge of lambda 2? He gave me that lambda 2 is negative. And I know that the electric field generated by a wire along a point that is along the same direction of the wire is either towards the wire or away from the wire. أنا هيدي بعرفها. يعني لقيته بس بدي أرسمها بتناسب مع نفس الخط طول الواير يا لعنده يا away. لأنه lambda 2 is negative, so I must draw lambda 2 along towards the wire along y-axis. So you can see from our discussion that E1 must be positive along x-axis and E2 must also be positive along y-axis. Okay, this is the geometry of the figure, and we have chosen the part A to be our answer because you can see that we have a positive x direction and a positive y direction. So here is our answer. لو كان اللامدا 2 for example positive كانت رح تطلع معي ال E2 لتحت. So in this case we will get the total electric field, which is the sum of E1 plus E2. It has a positive x and a negative y. But in our case, we had a positive x and a positive y. Okay, I hope they are clear. I'll try to solve questions as much as I can. Okay, I will now start with, let me share my presentation. So,
دكتور
نعم.
نحن we can't just study the cases، لازم نشوف البروف ما هيك بالهيدا البوكس.
لايكو بالنسبة للسوليوشن you may write them in يعني in brief. You may do that. يعني أنا بعرف when students solve too much بصيروا يقفوا steps، بصيروا يكتبوا أول step وآخر step because they already know
لأنه هن
where
ستاندرد. يعني مثلا هيدا example الانفينيت واير دايما حيطلع كي لامدا over d.
You may start and end with the answer. It's okay. So we know that you know the source of your answer, but not just write the answer. Okay, so we must see something solved, something that indicates this is not this is not cheating. If I just see the answer, so I may guess it's a cheating. Okay, so you have to write something that says that you are thinking, you know where your answers are
يعني
coming.
proving هيدي ال final answer.
بس ما ضروري with complete details. You may write just إذا أنت عم تحلي لحالك بالبيت ما بتكتبي شوي هيك حتى توصلي للأنسر. Do the same.
اوكي دكتور فينا بس تخلصي explaining Gauss نسألك عن السيشنز اللي حليتيهم؟
إذا بقي معي وقت لأنه أنا عندي كمان سيشن وراكم الوقت اللي بيبقى معي. Okay, so let's start with Gauss's law. So Gauss's law is very, very important, okay? And it's an easy method to calculate the electric field, and it's somehow, you can enjoy it when you solve using Gauss' law. It's easier, too much easier than using the first method, which is Coulomb's method. So as I have said, and we used Coulomb's method, we said that if we want to find the electric field generated by a distribution of charge, we have to integrate k dq over r square u, okay? And as you have seen, some problems with just one dimension, they needed too much integration to find the answer, okay? So using Coulomb's method needs effort, it needs integration. Gauss came up with a new method that allows us to calculate the electric field, okay, generated by a certain charge Q, but this method is only applied to systems with high degree of symmetry. So I can't apply it Gauss law, okay, I can't solve Gauss law using any system. It must be a system with high symmetry. When I go through the slides, you will understand what do I mean by that. So if we have a sphere carrying a charge, we can find the electric field generated by this sphere. If we have a cylinder, it has a cylindrical symmetry, we can find the electric field generated by a cylinder. Wire, it's the same as a cylinder, but wire, it has a very, very small radius. But if we have, for example, a part of a sphere, so this is not symmetrical, it will be very hard to find the electric field generated by a part of a sphere. Okay, هلا does Gauss law stay valid if we have a non-symmetrical object carrying a charge? نحن عم نحكي عن objects that are carrying a charge and creating an electric field around them in space. Gauss law remains valid. It's a law. It's never wrong. It's always true. Okay, but integrating Gauss law in this case becomes impossible. So if E is variable, or if the shape is a variable, if it is not يعني منه سهل, it's hard to integrate, and if we can't integrate over the shape, so we can't have an answer of what we are looking for. So let's start talking about electric flux in order to move on to Gauss's law. So رح أرجع أعيد. The aim of this chapter is to find a new method to calculate the electric field other than Coulomb's method. Okay, this method is easier and it can be applied to systems with high symmetry. What are the systems? You will memorize them once we start solving. When do we apply apply Gauss's law? If we have a plane, if we have an infinite wire, if we have a sphere, if we have a cylinder. So for only these objects, we can apply Gauss law, or we will see how to apply Gauss law. When do we apply Coulomb's method, integral k dq over r square u? If we have, in our course يعني نحن, if we have a segment, if we have an arc, one wire, شو بعد في عنا أخذنا فيه نحن بالكولومب. So these are segment, semi-infinite wire. Infinite wire, we can apply both. Okay, the plane, we can apply both, but it's not required in the case of Coulomb's method. So this is the differences between both methods. So when you see the problem, you must directly distinguish, should I apply Coulomb or should I apply Gauss? Okay, they appear clearly that you should apply this method. Okay, so what is an electric flux? Let's start. What is an electric flux? Let's consider an area A flat area A, placed in a uniform magnetic field E. As you can see, there's a magnetic field E, uniform. It means the electric field has a constant value, constant direction everywhere in the region. So as you can see, E is directed to the right. The electric field is always tangent to the lines of field, as I have noted earlier. So you can just imagine the electric field, how it goes everywhere in this region. So the number of electric field lines crossing the area, so the number of lines of field crossing this area, this blue area, represents the electric flux phi. I know you all have studied something called magnetic flux. What is the magnetic flux? It used to be B dot S or NB dot S. It is the number of lines of field crossing an area, okay, but lines of field of magnetic field. Here we are not talking about magnetic field, we are talking about the electric field. So the electric flux is similar to the magnetic flux, but instead of talking about electric field crossing an area, we are talking, instead of talking about a magnetic field crossing an area, we are here talking about an electric field crossing our area A. So what is the flux? Again, it is the number of lines of field, the number of lines of electric field crossing my area A. So by definition, what is the electric flux phi? It is E dot A. What is A? It is the vector, surface vector. A vector, it is the vector perpendicular to the area. Its magnitude is equal to the area, and its direction, it's perpendicular to the area. So you can see here from my figure that A vector, this is A vector. Sorry, this is A vector. It is perpendicular to the area. So A vector is perpendicular to the area, the blue area. And A vector can be written as An, where N is a unit vector perpendicular to the surface. So we can draw N, it's the same as A. This is the electric field crossing them. So E dot A is simply E A cosine angle between E and A, or E and N. So because A and N have the same direction, so we can either say it's the angle between E and N or the angle between E and A. This is the electric flux phi. So phi, the electric flux, it's E A cosine theta. This flux will be linked to the charge. Okay, we will see how. So this is for the electric flux. What happens? This is true for a uniform electric field and for a flat surface. But what happens if my surface is not flat or my field is not uniform? How to calculate the electric flux? كيف احسب الفلكس بهالحالة؟ اوكي هي E A cosine ثيتا إذا كان كل شيء يونيفورم، المساحة أو الاريا جالسة، الإلكتريك فيلد هو يونيفورم. بس إذا كان الإلكتريك فيلد منه uniform, it's variable everywhere in space. And if my area is not flat, what do? We do the same formula, but instead of taking all the surface together, we divide our surface to small areas dA. So this is a small area. So because the area is very, very small, I can say that this area, okay, it's very small, not like it is drawn here. يعني هي كأنها نقطة بس. Okay, it's very, very small in the size of a small point. So because it is in the size of a small point, I can say that it is flat. It can be considered flat. It can be considered flat, and the electric field inside crossing this small area will not change. هو كتير صغير الاريا فما راح يلحق الالكتريك فيلد يتغير فيها. So in this very, very small area, I can say that the electric field here, it is simply E dot dA. Okay, I have written it here as E dot delta A. Delta A, it means a small portion, but dA is a very infinitesimal portion. Okay, so to find the total electric flux crossing my area, this blue area, so I add all the small areas, the small elements, or all the electric fluxes crossing the small elements of area delta AI. So I add all of them. When I add all of them, I get the total electric flux. So as you can see, phi, it's equal to E1 delta A1, E2 delta A2, etc. so that I can add all the electric fluxes coming from our crossing the small elements of area delta AI. Okay, so usually we don't consider delta A. We consider something to make it really work. We consider the infinitesimal form of the area. So instead of delta A, we take it as dA, and the summation will turn out to be an integral. So phi, which is the electric flux, so this formula phi equals E dot dA. This is the electric flux crossing an area A. This area A may not be flat, or the electric field crossing an area is not constant. So I can't simply just say phi equals EA. I have to say that phi equals integral dA. What is this? This is the electric flux crossing an area A. Till now we have two formulas. Either EA is true, electric field constant, surface flat. This one, if one of them is not okay, I have to use the integral form. Okay? So, a closed surface area. What do we mean by a closed surface area? A surface that is closed. For example, surface which is external surface of a ball. This is a closed surface. surface بس مسكرة. Okay, balloon من برا هيدا surface. Okay, so this is a closed surface. So I can also find the electric flux crossing a closed area. Why do we introduce this this notation, which is a closed area or flux crossing a closed area? Because Gauss law will be related directly to the flux crossing a closed area. Okay, so if we have a closed area, so assume we have this is a spherical shell، يعني قشرة طابة بس ما هي area لازم تكون، وأنا عم شوف شو هو الفلكس اللي مارق فيها. Okay, so I'm looking at the flux that is crossing my area, my closed area. So at each element, at each point of my surface, dA is an element of area perpendicular directed towards the exterior of the closed surface. So you can see that dA has different directions everywhere, but is the element of يعني كل ما dA بتكون هيك. You will see why do we explain it later when I move on. So dA by hypothesis, because you know إذا أنا بدي أرسم perpendicular على surface, I can either draw dA inside or outside. So by hypothesis here it is always taken outside the closed surface. Okay, لأنه في عندي two options to draw the perpendicular vector along a surface, either inward or outward. So here it is taken to be outward. Let's do the small application. This is easy. Okay, I have this cube. It has a side L. The cube has 6 sides. Okay, 1 up, 1 down, and 4 from the lateral side. Okay, I've tried to number them. We will work on both on the 6 of them together. هلا, we have to find the electric flux of a uniform electric field, which is directed along x-axis, crossing this cube. Okay, so we are going to find the electric flux phi. Because the cube is formed of 6 different sides, I have to calculate each side alone, the flux crossing each side alone. If you want the total electric flux crossing this closed surface, this is a closed surface بس القشرة تاعت البوكس. Okay, this closed surface, simply you have to add them. So I have to do each one of them alone, and at the end we have to add them. We can't do all of them together because each side has its own direction. They are different. So we have to do each one of them alone. هلا, let's start with the easiest ones, which are 3, 4, 5, and 6. ذكروا electric field هو على x-axis. I will start with the 3. 3 is this face, which is up. Okay, اللي من فوق. First, you know that أول شيء electric field أنا عندي uniform, it's not variable, and my surface is flat. I can use the formula phi 3 equals E dot A. Okay, A3, no problem. I can use this method because it's flat and E is uniform. And also I can use E dA. It's also true. Why? Because in this case, if E is a constant, E goes outside the integral. So dA, so you will get the same formula E dot A. Okay, so you can use both of them if the flat is surface. So you can, here appears dA. So it's okay. هلا أنا فيني استعمل E dot A. أنا عم بشتغل بس على السيرفس اللي هي 3. E dot A. ما رح استعمل integral. No need because E is not variable ولا السيرفس عندي هي it's flat. So it's simple. EA. Because E and A are perpendicular بحالتي أنا ال E عندي هي along x axis يعني هيك. وال DA it is perpendicular to the surface أو ال A3 it is perpendicular to the surface. To the exterior side of the box دايما لبرات البوكس بتكون perpendicular. Anyway, they are forming an angle of 90 degrees. So EA cosine 90, it will be 0. So أول شيء ال Q3, it is 0 for this reason. Why? Because E is perpendicular to the area A3. نجي عند ال 4. Where is 4? It is the one, it is in the XOZ plane تحت. Okay, so this is the 4. كيف برسم ال A4 أو ال A4 كيف بتنرسم؟ ال A4 it is a vector, it's the area vector perpendicular to the surface to the exterior side like this. So this is A4. As you can see, A4 is also perpendicular to E. So E is perpendicular to A4. Because E is perpendicular to A4, then Q4 equals E dot A4. So I will get E times A4 times cosine 90. So I will get also 0. Okay? بمفهوم آخر ما عم يفوت فيها lines of field. ما هي جاية مثل اتجاه اللاين، ما عم يفوت بقلبها lines of field. So الفلكس اللي فايت فيها الزيرو. ما عم يفوت بقلبها شيء. اوكي، شو يعني الفلكس زيرو؟ يعني اللاينز اوف فيلد اللي عم يقطعوا بقلب هيدي ولا شيء، ماشي. مين عم يقطع فيه لاينز اوف فيلد فعليا؟ هو الوجه اللي من هون هو مسميه 1، والوجه اللي من هون اللي هو مسميه 2. هو بس عم يقطع فيهم فلكس. يعني اذا انا عم شوف الخطوط اوكي هن بس عم يقطعوا من ال1 وال2. الثلاثه والاربعه ما عم يفوت فيهم لاينز اوف فيلد، والواحد والخمسة والستة كمان ما عم يقطع فيهم lines of field نتيجة الشيب للسكوير تاعولي. اوكي، سو بهيدي الحالة بما انه ما فيهم lines of field physically لازم يطلع الفاي تاعولهم صفر والا there's something wrong. So let's do now. رح اعمل هلا الخمسة والستة. الخمسة where's 5 الخمسة هي اللي نحن لجهتنا، يعني انا شايفتها من هون. Let me just okay, just help you see which one is 5. So this is 5. هيا 5. هذا الوجه اللي هو 5. So if I'm going to draw A5, so A5 I'll draw it like this. This is A5. كمان A5 is perpendicular, so this is E like this. I hope you can imagine in 3 dimensions. So don't worry, this is the only question that needs such type of work. Other questions, they are all similar and you can just figure the answer yourselves. So كمان على A5 we draw A5 the area vector perpendicular to the area towards the exterior. Because here in our case A vector and E they are perpendicular, so we get phi 5 equals to 0. Similarly phi 6, where's 6? 6 هي الوجه اللي من هون اللي نحن مش شايفينه من ورا. Okay, so no flux passes through these surfaces. No flux passes through these surfaces. Let's go back to find the electric flux crossing 1. Where's 1? 1 is the surface that also we can see this surface. I hope you can imagine it. It's found here. هيدا السيرفيس اللي من هون نحن مش شايفينه، هيدا ال1 من هيدي الجهة. Okay, so if I want to draw DA, so DA is drawn like this, DA1 or A1. ما هي ال A1 هي كل الاريا، كمان الفكتور تاعيتها نفس الشيء. It's a flat area, so nothing will change. you can see that if I'm going to draw A1, it has an opposite sense to E. So E dot A1 will simply give me E A1 cosine pi, and it's minus LE cosine pi, it's minus 1. الاريا it's equal to L square, which is the area اللي هي الوجه واحد عنده area side by side, it's L square. So I will get minus LEL square. Let's do now phi 2, which is the flux crossing area 2. So I have drawn already dA2. أصلا dA2 مثل A2. They have the same direction. They are both perpendicular to the flat surface. So A2 has the same, I've drawn it like this. So A2 have the same sense as E. Okay, so we will get E phi 2 cosine 0, and we will get EL square, because the area for sure it is L square. So if I'm searching for the flux crossing a closed surface مثل الكيوب، يعني بس قشرة الكيوب قد ايه عم فيها total flux, I add the total fluxes from different surfaces. I add phi 1 with phi 2 with phi 3 with phi 4 till we get our answer. Here in our case we get 0. Why do we get 0? Well, I will explain why in the coming slides, but I have to tell you something, that lines of field were entering through surface 1, and the same amount of lines of field were leaving through surface 2. مثل ما شفتوا كان طلع معي Q1 هي ناقص EL square، يعني this is the number of lines of field crossing. ليش minus? Because they were entering. بينما phi 2 it is positive. It means that the lines of field at this surface were leaving the surface. أنا كمحصلة قد ما عم يفوت قد ما عم يظهر عندي lines of field. Okay, this is why we get a 0 total flux crossing our cube. This is the reason why we get a 0 electric flux crossing our cube. We will explain it more, and you will understand it more when I explain Gauss law. Okay, so till now you have just to understand what is an electric flux and what do we mean by a flux over a closed surface. Okay, remember أنا ما عم بحكي عن حجم، ما عم بحكي عن فوليوم، يعني أنا ما بيهمني شو في بقلبه للكيوب من جوا، بس بيهمني القشرة البرانية تاعت الكيوب، السيرفس البرانية تاعت الكيوب، بشوف الوجه تاعه شو عم يمرق بقلبه electric field. Okay, let's move on. Now we are going to try to do a proof for Gauss law. For sure, shouldn't memorize the proof, but you should know it, because knowing things makes understanding them easier and makes believing them more easier. So we will try to just understand Gauss law and where does it come from and where does it lead us to. Let's consider a positive charge Q. This is our positive charge. It is surrounded by an imaginary closed surface A. So this is surface A. It's a closed surface. ما تتخيلوا أنتوا كأنه هو عبارة عن واير. هيدا مش واير، هيدا surface. تخيلوه كيس، بالون، شيء عنده dimension بس إنه بس القشرة تاعيته. Okay, this is a surface. We are going to take a small portion of our area. This is a small portion of our area, dA. And we're going to check the electric field crossing this area. So راح يمرق أكيد. So I will draw dA. This is D. This is dA. This is the vector ونرسمها. Assume أنا عم يجي عندي electric field بهالطريقة. أكيد electric field. I will redraw it. Okay. So I will take a portion here. Where shall I take it? Okay, so I will take dA here. So this is dA. Assume this is dA. This is dA vector. Okay, so this is dA vector. And هيدي الفكتور اللي هي يعني هيدي البورشن الصغيرة من الاريا أكيد بده يمرق فيها electric flux. The electric flux here, this is the electric flux. كيف بنلاقي electric flux؟ أكيد for example if Q is positive I draw this is R so I've drawn it somewhere else محل ما هو رسمها كرمال بس نشوفها منيح. So if Q is positive then E is drawn away from the charge Q like I have drawn along the line joining the point and Q. dA, what is dA? It is the element of surface بتكون perpendicular على surface لبرا. Okay? Perpendicular على surface لبرا. So E as a value it's equal to KQ over R squared. This is E. Let's search for the electric flux crossing this small area. نحن قلنا d phi electric flux crossing this small area is simply E dot dA لأنه هي كتير صغيرة الاريا so I can just multiply electric field by area because I can consider it as a very small portion where the electric field is constant. It can be just area times electric field. Substitute everything. It's EA cosine theta. EDA cosine theta. E is substituted with KQ over R squared. DA remains the same and cosine theta remains the same. Okay, now this term here, DA cosine theta over R squared is defined in geometry as a solid angle. This is called solid angle. What is a solid angle? You are not responsible for solid angle. I will just rapidly explain it. Okay, and I will go through the derivation. نحن الانجل اللي بنعرفها this is an angle in 2 dimensions. هي الانجل العادية. So this is our angle. This is theta. نحن بنعرف إنه our angle theta varies from 0 till 2 pi. So this is our angle theta and its unit is radian. This angle that I'm talking about هي between two lines in 2 dimensions. This is the normal angle that we all know. What is the solid angle? The solid angle هي الانجل ب 3 dimensions. اوكي يعني إذا بدكم to make it simple إذا أنا عم طلع على زاوية كأنه عم طلع على هيدي الزاوية اللي هي كعب الكون أو هيدي إذا أنا عندي كون أو إذا بدكم حيلا شكل مثل الكون عم تطلعوا على الزاوية الموجودة جوا هيدي الزاوية اللي هون. أوكي هيدي اسمها solid angle. Angle in 3 dimensions. منا angle in 2 dimensions. It's an angle in 3 dimensions. اوكي هيدي الانجل اليونت تاعتها منا radians عندها يونت اسمها steradians. So the unit of solid angle is steradian. والبرمة كاملة منها يعني لما انا ببرم برمة كاملة بالسبيس اوكي على دورة كاملة بتطلع عندي 4 باي مش مثل هون اذا انا بعمل برمة كاملة وبرجع لمطرحي بيطلع عندي 2 باي. no هونيك بتعطيني 4 باي. So this solid angle which is omega وهي equals أو ال closed integral of d omega. إذا أنا بعمل برمي كاملة يعني بالسبيس تاعولي بالسبيس يعني الأنجل الكبيرة للسبيس أوكي بتطلع عندي 4 باي steradians. Okay, I hope it's clear. If you don't find it clear you may ask at the end or you may search for online for a YouTube which helps you understand more solid angles. Okay, but anyway it's not required. Let's now make our formula. نحن رح نعمل الفلكس. So نحن عنا d phi which is the element of a flux crossing small area dA. To find the total flux crossing all my area A I have to integrate. So إذا ما أنا معي d phi equals E dA. So integral d phi اللي هو phi. So phi I will get equals closed integral E dA. This circle here هيدي السيركل الصغيرة means that our surface is closed. I cannot apply Gauss's law if my surface is opened. Then I must apply it on a closed surface. So I'm applying it on a closed surface and my surface أصلا هي closed surface. And by the way, this surface is an imaginary surface. يعني ما ضروري يكون في شيء حواليها. أنا مختارة surface من راسي ما في شيء. Okay, so there's nothing in reality. This is an imaginary surface. So it's EDA. I just have to integrate here. Just I have to erase all. Okay, and we have to integrate here, integrate here, integrate here. So as you can see, KQ goes outside the integral. KQ, they go outside the integral. There remains DA over dA cosine theta over r square, which is d omega, integral d omega over a closed surface يعني برمي كاملة بالسبيس على solid angle. This will give me 4 pi instead of this quantity. So substituting for k 1 over 4 pi epsilon 0 عوضنا محل ال k 1 over 4 pi epsilon 0 طلع معي بالآخر phi the total electric flux crossing a closed area is equal to q over epsilon 0. What is q? It is the charge inside my area. This is the result. Okay? Let's express or re-explain the relation again. Till now, what did Gauss find? Gauss found that if I have a closed surface, the total electric flux crossing this closed surface is equal to Q, which is the charge inside this surface, over epsilon 0. This was the idea of Gauss. This was the relation of Gauss. Okay, till now it's okay, but I have to make more conclusions. What happens if we have one charge, two charges, so they are noted just as the remarks. So using these remarks, we will reach the final Gauss law. This is the final Gauss law, by the way, but I'm writing it in a more more applicable way. So let's first see different surfaces. احنا اتفقنا انه السيرفيس اللي احنا عم ناخده السيرفيس اللي احنا عم ناخده هو imaginary surface. أنا باخده بشكل عشوائي. I will teach you how to choose it, but I can choose logically. I can choose any surface I like because it just applies to a closed surface. So according to Gauss law, the electric flux crossing area A1, electric flux crossing area A2, والflux crossing A3, والflux crossing A4 must be all equal, despite that they have different shapes. Why? Because شو ما كان شكل الفلكس، شو ما كان شكل عفوا السيرفس، بالآخر رح يكون الجواب equals Q على epsilon 0. الكيو هي التشارج اللي جوا. وين ما كان مطرحها، ما بين معي أنا إنه مطرحها له خصة، هو طلع لحاله في Q على epsilon 0. ما في لا positional Q ولا قد ايه كبير السيرفس ولا شيء. So according to what we have derived, it appeared that the size of the surface, the shape of the surface, the position of the charge doesn't matter. Integral EdA over any surface بشرط انه دايما الكيو هي جوا. اوكي رح يطلع معي هي الكيو على epsilon 0. So شو معناتها هيدي؟ إذا أنا بطلع on the figure to the right, we have three surfaces, S1, S2, S3. S1 is a spherical surface, يعني مدور. S2 is an arbitrary surface, it's irregular. And S3 is also irregular. I have a charge Q inside. According to Gauss law, إذا أنا بحسب الانتجرال EdA على ال S1 أو الانتجرال EdA على ال S2 الفلكس اللي مارق بال S2 أو بحسب الانتجرال لل EdA على ال S3 الفلكس اللي مارق بال 3, all of them will give the same answer اللي هي Q على epsilon 0. Physically, why? Because the flux calculates the number of lines of field crossing an area. انتوا شايفين ال lines of field. These are the lines that are colored in brown or okay, something like that. نفس عدد ال lines of field اللي قاطعين ال S1 is the same as the number of lines of field crossing S2 is the name of same number of lines of field crossing S3. هيدا هو السبب انه الانتجرال EdA على S1 هو نفسه الانتجرال EdA على S2 هو نفسه الانتجرال EdA على S3 because integral EdA is the electric flux. It is the number of lines of field crossing an area. ومنطقيا ما هو الفيلد طالع من النص ورايح لبرا، فإذا مرق بهيدا رح يمرق هو ذاته بهيدا. Okay, so this is for the first remark. The first remark says what's important now, the shape. Okay, we can choose any shape we like if we are searching for an electric field. Next, let's check what happens if Q is outside the closed surface that I'm choosing and not inside that surface that I'm choosing. نعم. نعم.
دكتور حدا فاتح المايك بالغلط.
هيك الظاهر. Anyway. Yeah, I will. Okay, I will complete. Now, second remark. What if the charge is outside? What happens if the charge is outside? You know that integral EDA equals integral, this is the flux phi, equals integral EDA. This is the number of lines of field crossing an area. ونحن اتفقنا if the lines of field are arriving رح يطلع معي electric field negative محل ما هني arriving, and if they are leaving رح يطلع معي electric field will be positive. So because the number of lines of field entering a closed surface is equal to the number of lines of field leaving that surface, we will get a zero electric flux crossing this surface. So what do we deduce? إنه electric flux اللي عم تعمله charge برا ما بيعمل total flux مارق بالelectric field ما بيعمل total flux مارق بالسيرفيس تاعيته. I will re-explain why. طلعوا معي بهيدي الحالة. كم لاين عندي؟ عندي واحد مارق بالاثنين 3 4 5 5 فايتين و5 كمان ظاهرين. كتوتال كم واحد قاطع السيرفس تاعولي؟ ولا واحد. اوكي؟ because entering lines of field بيعطوني negative flux و leaving lines بيعطوني positive flux. so overall شو تأثيرهم على كل السيرفس overall? nothing. So we can say that the charges that are outside the surface do not affect the total flux crossing the surface. So إذا عم بحسب الفاي total لكل السيرفس اللي برا ما بتأثر، لأنه إذا هي عم تعمل lines of field على جهة رح تكون inward، على جهة الثانية رح تكون outward، كمان كتوتال تاعولها رح يطلعوا زيرو، فما لهم أهمية. This is the second remark. Let's move on to the third remark. If we have many charges, what do we do? Okay, all the charges that are outside لكل اللي برا عندهم بيعملوا total flux zero. يعني هيدي وهيدي 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 كلهم the flux due to charges outside are all zero. ما بهتم لهم أنا، ما بطلع فيهم أبدا. مش إنه ما بيعملوا هني electric field، من بلا بيعملوا electric field، بس كتوتال تأثيرهم ما بيبين معي كفلكس. اوكي حسب قاعدة Gauss. So integral EDA ما أنا بدي أجمع الفلكس of all charges. I can add the flux of an external charge بس ما هي الفلكس تاعولها زيرو. I don't take it into account. What remains is that charges that are inside. Okay, they can be positive, they can be negative, it's okay. So Q1 will create an electric field, Q2 will also create an electric field, and all the charges will create electric fields. So simply the total electric field is equal to the sum of individual electric fields. Okay, we will make our proof here. So إذا أنا عندي element of area dA عم يقطع فيها electric field E. This electric field E may be coming from different charges موجودين جوا. So what are AI? AI is the sum of electric fields coming from different individual charges found inside the surface تاعولي جوا بقلبه. Okay? So it is E1, E2, E3. E1 is the electric field due to 1, E2 is the electric field due to E2, etc. Okay? I know that
دكتور فيكي تعيدي شو هي EI؟
EI ما هي نحن قلنا انه انا عندي جوا تشارجز Q1 Q2 في فيلد E1 انا رح اخذ small surface DA مثل العاده. اوكي عم يوصل على DA electric field E. This electric field E هو مجموع الالكتريك فيلد اللي جايين من ال1 وال2 وال3 وال4 صح؟ وقد ما كانوا تشارجز جوا. So الانتجرال EDA إذا أنا بدي أجيب total flux بدي أعمل انتجرال. انتجرال EDA الإي هي sum للindividual electric fields، هي E1 زائد E2 زائد E3 ولا لا؟ Is it okay?
صح.
Okay, so I will get E1 plus E2 plus E. ال E1 هو electric field أو الفلكس لنتيجة ال Q1. So it's simply Q1 over epsilon 0. Integral E2dA هو it's the electric flux crossing my surface due to Q2. It's simply Q2 over epsilon 0. وهكذا till I finish up by the summation of all charges inside my surface over epsilon 0. So I will get Q inside over epsilon 0 or Q enclosed over epsilon 0. This is the last formula of Gauss. يعني هذا الشكل النهائي هو احنا بنقول integral EDA equals Q inside over epsilon 0. Okay, so شو لازم نخلي ببالنا؟ First, we have to choose a closed surface and we apply integral over this closed surface. هيدي أول شغلة. This closed surface must be chosen يعني نحن حسب ما شفنا we can choose it any way we like, but to make integration easy it must be chosen in an appropriate way. We will learn how when we solve. Okay. Second, Q, we only take charges inside the surface towers. Charges outside are not taken into account because outside charges lead to a zero electric flux. They did not affect the total flux crossing my area. Okay, so I have to keep this in mind. So to solve our problems, you have seen that we have to choose a surface. This surface is called Gaussian surface. Relative to Gauss, so it's called Gaussian surface. This surface is usually imaginary surface. It can be real, but it's just a surface. We just assume we have here a surface. And we try to find the electric field crossing this surface. يعني احنا عم نجيب الفلكس اللي عم يقطع بهيدا السيرفيس أو electric field اللي عم يقطع بهيدا السيرفيس. Okay? We usually choose the electric field to be constant over a surface to make integral easy and applicable. Otherwise, if our shape is if it's not symmetrical, solving this integral with EDA will be very, very hard and it will be impossible. So we usually apply Gauss law for things with symmetry. Why? Because we need to solve this integral, and if it is symmetrical, solving it will be so much easy. This is the last slide, I guess. So this is an explanation of the way how we are going to solve using Gauss law. So رح حل شيء something very simple. كلنا نحن بنعرف إنه the electric field created by a point charge at a distance r هي k dq kq over r square. يعني إذا أنا عندي charge q هون I will draw it here وأنا بدي أجيب electric field هون على point m. So you all know that the electric field here, it will be like this. So if Q is positive, assume Q is positive. So the electric field E will be like this. And its value is KQ over R square. What is R square? It is R, it's the distance between the charge and point M. هيدا نحن بنعرفها. Okay? How to do the same, how to find the same answer using Gauss law. The point بالنسبة لإلي هي عندها spherical symmetry. يعني كيف يعني؟ All the points that are equidistant from R نفس المسافة عندهم نفس ال E. يعني إذا أنا عندي نقطة هون نفس المسافة بعيدة عن ال R مش عندها نفس ال E كقيمة. So it has radial direction بس كقيمة قيمتها كمان KQ over R square. كمان هون إذا أنا عندي نقطة كمان عندها E equals KQ over R square. So we can see that this Q has some sort صحيح نقطة but it has some sort of spherical symmetry. يعني all points that have the same distance from Q, they have the same electric field, the same magnitude of electric field. The electric field everywhere is radial. It is directed away from Q. شكله مثل الراديال. Why? Because remember, if I draw the lines of field of Q, lines of field of Q. The electric field شكله دايما away from Q radially outward. So this is E. Okay, so هيدا عم نحنا نعمل discussion شو ممكن نحنا بنقدر نعمل. So let me erase. We have our charge Q. So in order to calculate the electric field generated at a certain point, we choose a Gaussian surface. هالGaussian surface هو spherical Gaussian surface. يعني ما كنت تتخيلوه كأنه قشرة طابة. هو مش 2 dimensions هو 3 dimensions. This spherical Gaussian surface الQ موجودة بالنص تعولوا لهيدا الGaussian surface. Okay, and I'm trying to find the electric field على هيدا الGaussian surface. هلا أنا بعرف إنه كل النقط على هيدا السيرفس أنا اخترته عندهم نفس الإي، نفس قيمة الإي، لأنه وين ما كان distance هي ذاتها، لكن قيمة الإي هي KQ over R square. أنا هيدي بعرفها. So I know that the magnitude at the same distance is the same. So let's apply Gauss's law on this surface that I have chosen. So we just apply Gauss's law, it's easy. Integral EdA equals Q inside over epsilon 0. أول شغلة بعملها برسم بنقطة معينة، برسم الE والDA. أنا معي الE must be radially outward، وكمان الDA بكل النقط هي كمان perpendicular للسيرفس لبرا. إذا أنا بختار نقطة تانية كمان الE رح تكون هيك والDA مثلها، كمان DA perpendicular to the surface والE هي radial، بنقول الE is radial and DA is also radial لأن هي perpendicular لcircle أو لsphere. Here everywhere you can see that everywhere E and DA they have the same sense. DA is perpendicular to the surface والE هي radial شكلها. ثاقبوا هون طلعوا معي مثل بعض. Okay, so E, this is DE and this is DA. So we can say that E is parallel to DA. We replace E dot DA, just let me finish. We replace E dot DA with cosine 0, EDA cosine 0 because they have the same sense. Okay, هلا along this على هيدا الجاشيان surface قيمة الE ثابتة. أنا عم بشتغل عم بعمل انتجرال على الجاشيان surface. So we take E outside the integral بيطلع معي الE لبرا. يبقى معي DA. What is DA? DA is the integral over the Gaussian surface that I have chosen. على السيرفس اللي أنا اخترته. هذا الاريا قد ايه لإله؟ we memorize it. It is 4 pi r square. What is 4 pi r square? هي مساحة السفير من برا، قشرة السفير من برا. Shell of the sphere كاريا. Okay, it's 4 pi r square. So طلع معي أنا بالآخر إنه E times 4 pi r square equals Q over epsilon 0. Divide by 4 over pi r square, 4 pi r square. You will get Q over 4 pi epsilon 0 r squared. So it is KQ over r square. So we will get the same answer as we have already done using Coulomb's method. Our Coulomb's method, he found it. He did not calculate it, but he just found it. Okay, anyone has a question concerning the slide?
دكتور أنا عندي.
Tell me what.
اوكي، قلتي هون انه الاي والاي عندهم same sense.
True.
بيطلعوا parallel. ليه ما فينا نرسم مثلا وحده الاي تكون عادي perpendicular بس على جهه، وتكون الدي اي كمان perpendicular بس على جهه ثانيه، انه يكونوا opposite senses؟
No لأن مش أنت بتجمعي، مش أنت بس نحن بناخد infinitesimal area بنشوف بهالاريا الإي اللي مارقة فيها والدي اي تاعلتها.
يعني أنا حسب الاي برسم الدي اي.
لا، نحن بناخد infinitesimal portion من السيرفيس تاعولة. So this is an infinitesimal portion. على هيدي البورشن بترسمي بهالنقطة الإي والدي اي هن هيك. بس أنا عم أكد لك إنه هي بكل المطارح نفس الشيء.
بدي أعرف ليه.
Enough to draw it in one place only. So in this place here, E هي radial, هي away from Q. كمان ال DA هي perpendicular للسيرفس كمان مثلها. I can't draw them in two different positions. I have to draw them in the same position. Why? Because we calculate d phi. What is d phi? هي EDA. It is the electric field or the electric flux crossing the area DA. شو أنا بيجي بضرب electric field بمطرح تاني بالاريا هون أجيب لي d phi. بس صار معي d phi هي flux crossing my small area. So to calculate phi we simply integrate d phi and we get this formula integral EdA. Is it okay?
يس بس انا كان عندي كونسيرن انه ليه مثلا اذا رسمت الدي اي لفوق مثلا ما الاي هي حتى لانه عند البوينت تشارج هي بوزيتيف فيها تكون لتحت تكون كمان هي انه بعيده انه تكون opposing البوزيتيف تشارج الكيو. فهمتي كيف قصدي؟
لا ما فهمت بس
اوكي مش انا قلت انه دي اي
recording
رسمتها لفوق هيدي
كبير.
السيرفيس اريا
بس شوي